Alrighty folks, here is the final hardened knife. Still probably about 150, 200 degrees or so. Now you can see some of that anti-scaling compound kind of pops off in the quench, after the quench I should say, on its own. The stuff that doesn't pop off, we'll just go and put in some hot water and it will dissolve right off. But as you can see, that anti-scaling compound, there's no oxide buildup, there's no decarburization. Pretty much what you put in to heat treat comes right out in the exact same state in terms of your finish. So I'll go ahead and take this knife inside and get the rest of this scaling compound off, and then we'll take a file and check and make sure that we've attained full hardness on this knife, and then we'll put it in the tempering oven to temper. Alrighty folks, so here's the blade after getting all the anti-scaling compound off. There's a little bit of discoloration that happens sometimes on the blade. That's not really a big deal. I mean, this is not scale at all. In fact, not sure if it'll show up in the camera, but you can actually see the pattern welded pattern in this area. This is just some difference in surface coloration, but like I said, there's no scale on this blade, and most importantly, no oxidation occurred during heat treatment. Now the next thing to check is to make sure that this blade did indeed harden. If the blade didn't harden, then we have to go back and repeat the normalization process and repeat the hardening process. So the quickest and easiest way to check if a blade has hardened or not is to use a file. Now files are extremely hard pieces of steel. Most files are well over 65 Rockwell C or so. So we want to check and make sure that we got a nice hard edge on this blade. So if the edge is soft, this file will bite into it because the file will be harder than the edge. Now if the file skates over the top of the edge and doesn't bite into it, that tells us that this steel has reached its full hardness, since the file is also at full hardness. So if we just file on the edge a little bit, it's not biting at all. Check the tip, same thing. There's no bite on this file whatsoever. You can hear how it kind of makes that higher pitched noise. That file doesn't want to bite at all. I could rub on this all day and it's not going to do anything to that edge. It's not going to pull off any material. So that means that this knife is 100% fully hardened. It has a full martensitic structure. Martensite is the microstructure that forms when you quench steel and fully harden it. So martensitic steel is fully hardened steel. Now in its current state, the steel is extremely hard, and if I put an edge on it, it would take and hold a very good edge. However, if you put any kind of abuse or use to this knife, it's extremely brittle. It's so brittle to the point that if you tried to use it for a general cutting task, or if I were to drop the knife right now and it landed on the concrete floor, it would shatter, it would crack and break into pieces. Now obviously a knife is not much good if you go to use it for a cutting task and it breaks. So we need to actually remove some of this hardness, just a little bit of hardness, and impart toughness. Now the process to do this is known as tempering. Tempering is basically heating this blade up to a much lower temperature than we did during our normalization or hardening. In this case, roughly 400 degrees Fahrenheit, and hold it there for an extended period of time. I usually temper for at least 2 hours. and I usually do a couple tempering cycles. But what this does is it allows some of the trapped carbon atoms from within that martensitic microstructure to kind of escape, and the microstructure of the steel relaxes, if you will, enough that it increases the toughness and makes this knife very hard to break and very hard to bend. So it gives it a lot of elastic properties. So you can, if you deform this knife, as in flex it or do something like that, rather than bend and take a set and permanently deform, it will rebound back to its original position. Now, tempering, like I said, will remove some of the hardness, but it comes with a trade-off. The ideal heat treatment for a knife is one that will hold a good edge, so it's hard enough to the point where it will hold a good edge, but tough enough and soft enough that you can use it for its intended cutting purpose without the edge chipping out, or without you breaking the tip or cracking the blade or whatever it may be. So different knives have different ideal heat treatments, and each different knife needs to be heat treated according to its intended use. Just as a comparison, this knife is fully hardened. This is a piece of some of the same steel that's in that knife, 1095. This is unhardened. So if I take this file on the unhardened piece of steel, it bites easily. I'm actually removing material right now. I don't know if it'll show up on camera, but that shiny line is actually material that I've removed from this piece of steel with the file. So same steel as what's in this knife. This knife is actually 1095 and 15 and 20, so this is the 1095 component. Same steel as what's in the knife, but unheat treated, unhardened, has very different physical properties. So heat treatment is probably one of the most important steps in making a knife. Many cultures historically that forged and made blades and weapons had the belief that it was during heat treatment that a particular blade got its soul, if you will. So early cultures recognized the significance of heat treatment, and you know, heat treatment in a knife gives you a usable tool. Without heat treatment, a knife is no more than a knife-shaped piece of steel. You can put an edge on it, but it's not going to hold an edge, and it's not going to be very useful. But after heat treatment, you have a very high performance cutting tool. So, as I said, the next step in heat treating this knife is tempering. So, what I have is a modified toaster oven that I made specifically for the purpose of tempering. So basically I took a toaster oven with all its heating elements, removed the factory control device, and put a PID controller in there and a thermocouple. And this oven will accurately maintain, again, within about 1 degree Fahrenheit of the set temp, whatever temperature you set it at. This provides really, really good accuracy when I'm heat treating my knives. So I'm going to go ahead and put the knife that we just hardened, that's in its fully hardened state. I'm going to go ahead and put this in the toaster oven to temper, and I'm going to leave it in there for 2 hours. 1 hour to ensure that it gets completely up to temperature, and 1 hour to allow any retained austenite structure or anything that needs to be fixed within the microstructure of the steel, if you will, to take care of itself, which typically, like I said, takes about an hour. So 2-hour tempering cycle. I'll pull it out at the end of 2 hours, allow it to cool a little bit, check it, make sure everything is nice and straight, nothing is moved, and then I'll go ahead and do a second tempering cycle. So we'll check back after the first tempering cycle and let you see how things are going. Okay folks, so I've got the knife here. It's been through all of its tempering cycles, and it is now ready for an edge flex test. Now, the purpose of an edge flex test is to check and make sure that the blade has been tempered to the proper level. So what you're looking for in a good high performance knife is an edge that is extremely hard to the point where it will maintain a really good edge but not chip out. If the edge is too hard, you can get really fine chips along the edge, which is very undesirable in a knife. On the opposite end, if your edge is too soft, it will actually fold over and not maintain an edge. So there is a very simple performance test that I do to all of my knives, which is known as an edge flex test, or some people refer to it as the brass rod test. So what I'm going to go ahead and do is grind a rough edge on this knife and basically sharpen it, and then I will take it on a brass rod and draw the edge across that and actually make the edge flex over the brass rod, and that will tell me, based on how the edge performs over the brass rod, if the edge is too hard and needs to be tempered more, if the edge is just right and flexes and returns to true, or if I tempered too much and the edge is too soft, in which case this knife would have to be completely reheat treated. So I'm going to go ahead and fire up the grinder and grind a edge on this. Alrighty, to grind my edge, I'm going to use this little slack belt area between my top idler wheel and the platen on my platen attachment. This area here has a little bit of give, so it's going to make kind of more of a convex edge, but it's stiff enough to the point that it's not really going to round the edge over too badly. So I'm just going to go ahead and grind a nice acute edge on this, something that's going to be really sharp. I typically never actually measure out a specific angle when I grind my edges. It's always based on just the feel and the sight and experience that I have from making a few knives and knowing what is required to get a knife sharp. So I'm going to go ahead and grind the edge, and then we'll do the edge flex test. Alrighty, we've got a rough edge ground on here. I can feel a little bit of a burr that is developed, or a wire edge, and the wire edge lets me know that I've gotten the edge down as thin as it possibly can be and still have enough material to support itself. So when you get a wire edge, you know that you've ground your knife edge down to the proper acuteness or thinness, if you will, and you know that that knife will be as sharp as it can be. So the next step is I'm going to go ahead and knock this wire burr off, the wire edge, and get the knife to a reasonable level of sharpness, and then we'll do the edge flex test. Alrighty, to pull the wire edge off of this knife, what I have here is a leather belt that actually goes on my belt grinder here. And the leather belt has been loaded down with a little bit of the white jeweler's buffing compound, and what this is going to do is this is essentially going to polish the edge and pull off that little burr, take off the wire edge there, and that will make a really sharp edge. It should be a razor sharp or shaving sharp edge after I run it on this strop here. So go ahead and do this. Check the edge and make sure that it's at the proper level of sharpness, and then we will do the edge flex test. Alrighty, now just to test the edge and make sure that it's at a good level of sharpness, I'm going to go ahead and take a little bit of arm hair here, and don't know how well this will show up, but just see if it'll shave any of this hair off of my arm, which I don't know again if it will show up in the camera, but it definitely shaves hair, so I know it's of good sharpness. I also have a piece of paper here, and we can use that to test and make sure that it is also of a good sharpness on the edge, which, based on the way it's cutting very smoothly, I would say that we have a very good edge on this knife. So now we'll take it over to the vise and clamp a brass rod in the vise and perform the edge flex test. Alrighty, so I've got a little brass rod clamped in my vise here. Typically you want to use something maybe around a 1/4 inch or so. This is a good bit smaller than that. This is probably more like 3/16, but it'll work for the testing purpose since I can't find my regular brass rod at the moment. So what I'm going to do is I'm actually going to hold the knife at an angle and apply some pressure. It doesn't have to be immense amounts of pressure, but it needs to be a fair amount of pressure at an angle right on that edge beveling. And what I am watching for is I actually want to see the edge actually flex around this brass rod. It may not show up in the camera, but if you do this in person, you'll actually be able to see the edge deform and flex around this brass rod. If the edge doesn't deform and it actually chips out, that means that this steel is too hard in this edge, and the edge is too hard for a good usable knife. And what that means is I need to take the knife and put it back in the tempering oven, turn the temperature up, say 10, 15, 20 degrees, temper for another temper cycle, and then do the edge flex test again. If the edge folds over as I draw it across the rod and it doesn't return back to its original position, then that means that the edge has been tempered too much and it's actually too soft for a good usable edge, and it won't hold a good edge, which is obviously something that you want in a knife, is a knife that holds a very good edge. In that case, I have to go back through, renormalize, reharden, and retemper the knife, this time at a slightly lower temperature than I did previously, and that will give me a slightly harder edge that hopefully shouldn't fold when I do the next edge flex test. So I'm just going to, like I said, start back here, apply some pressure, and I can see the edge deforming slightly around the brass rod as I'm doing this. Like I said, I don't think it's going to show up on the camera very well, but I can actually see the very slight edge form around that brass rod as I draw the knife across. Now that I've done it on that side, what I'm going to do is I'm going to run my fingers along the opposite side of the edge, and check to see if the edge folded over. Right now it doesn't feel like there's any kind of burr or folded over portion on the edge, so I'm going to assume that was a good test. Now I'll flip the knife over and repeat from the opposite side the test. Now again, I'm using a fair amount of pressure, but I'm not putting my whole weight into this. I'm just putting enough pressure to see that edge flex around that brass rod. And once I see that nice flex, I know I've applied the right amount of pressure, and I know that the edge has been hardened properly. So again, give it one more pass just for safety's sake. Again, I'm going to test the edge with my finger, just running it along the edge that I wasn't applying pressure to, testing to see if it feels like that edge is folded over or not. Right now it feels quite good, feels exactly the same as what it went into, and as I was deforming it I could actually see the edge returning back to true. And then of course the final test is to make sure that after the edge flex test, the knife is still as sharp as it was when it went into the test. So I don't know if this will be in focus or not, but I'm just going to check and see if it will shave any hair, which it definitely has shaved hair off of my arm. So I'm going to say that that knife is just as sharp as it was before I did the edge flex test, and that the edge hasn't folded. The edge certainly hasn't chipped. You can run the edge over your fingernail and it should be a nice smooth feeling along the entire length of the blade. So there's no fine chips or anything out of the blade. The edge hasn't folded over. So I know that this knife has been tempered to the proper degree for this steel composition and for the intended uses of this knife. Another performance test that I like to do with my knives is to test the tip hardness. A lot of times when people make knives, the tip will be too hard. Then if you're performing any kind of cutting duty where you're, stabbing the knife into something or applying any kind of tweaking force or bending force with that tip, you can actually break the tip off. This is a very common occurrence, and it's something that you obviously don't want in a knife, especially a knife that you will be using. So what I have here is a pine board, and this test is often referred to as a pine board test, or a pine board chip test, or whatever you want to refer to it as. But basically, pine is a relatively soft wood. It's not super hard, it's not super abusive on the knife, but if you stab your tip down into this board and you fold the tip over, it should peel up a chunk of this pine and your tip should remain in the same condition. If you stab this in and you fold the knife over and your tip breaks off, obviously your tip is too hard and you need to temper that area of the tip at a higher tempering temperature to impart more toughness in your tip. If you stab this knife into the board, you fold it over and the tip folds over and bends, that means that you've gotten your tip too hot and actually overheated it during the tempering process, and it's lost too much hardness, so now it is too weak and cannot maintain its nice point. So when you do this test, it's not a test that you want to embed a quarter inch of your blade into this piece of wood and then try and fold it directly over. It's more of a decent penetration depth and then folding over and popping up the wood. I typically do this a few times, going either way. As you can see, it's popping up those chunks of pine. I usually go a little bit more conservatively at first, just because if the edge is too hard, it will typically break right away, and I would rather chip off a little chunk of the tip than a big one. But after I feel it out initially, then I'll go a little bit more aggressive with it. Now what I'm going to do is I'm going to look at the tip and make sure that it hasn't folded on me, that it's still nice and straight, and from what I can tell, everything still looks good. So I would definitely say that this blade passes the pine board test. So that's just another performance test that you can do on your knives to make sure that your edge is of the proper hardness, your tip is of the proper hardness and toughness, and make sure that you've made a really good, usable knife.